So 15 relates to goal topic 4C, which asks you to find an equation of a line which is either parallel to or perpendicular to, depending on the context, a given line. So here you're given a line, y equals negative 5x plus 9. So this is our point of reference. And we want to know an equation for a line which is parallel to it and which passes through a specified point, 3 comma 6. So there's our mandate. First of all, anytime you're asked to produce an equation for a line, what immediately pops into your head? Yeah, exactly. That you will never go wrong by starting with a template, y equals mx plus b. Because what the template does is it just asks us, it begs the question, what is m and what is b? And if we can answer those two questions, then we've answered the full question. So we just have to figure out what values m and b should take. And if we can do that, then we're done. So first let's start with m. What does m represent again? Represents a slope of the line. So the question is, where are we going to get information from the statement of this problem on what the slope of our line should be?
One quick question. Everyone raise your hand. Which is, it's not a bad thing that you fell into the trap. It just means that the area you made is a lot different than as if you actually knew what parallel stood for.
So,
which means which one you have to focus on the most.
So how are we going to know in this problem what the slope of our line needs to be?
y2 minus y1 over x2 over minus x1.
So on the one hand, that's the definition of what it means to be a slope in the first place. And if the information that we are given includes the coordinates of 2 points, that's how we can find the slope. If we know the coordinates of 2 points, then probably a good idea to use that formula. So for example, question 22 on this exam. That's what you would have had to do on question 22. You're given a graph of a line and 2 points labeled on the line. You have to find an equation for the line. So the first thing you did was, let's find a slope, and because we know the coordinates of 2 points, we can use this formula to discover the slope. But in this problem, unless you want to work harder at it, we don't know the location of 2 points on this original line. So we're going to have to think a little bigger here. How are we going to know what the slope of our line that we need to answer this problem in particular has to be?
3, 6. We have to times the negative 5 by 3 and 6.
So the 3, 6 tells us, it's going to tell us the location of this line. It's going to kind of give us a sense of where this line is located in the xy plane. It has to go through that specific point. But a slope is not a location piece of information. It's more of a direction piece of information. Which direction does this line go? Is it increasing from left to right? Is it decreasing from left to right? Is it steep? Is it shallow?
And from there, you only have one other option. There's three key information given in that question. Parallel, y equals negative 5x plus 9, and the point 3, 6. We know that we can't get specifically we can't use location because that doesn't tell us anything. It just tells us a point on that line.
Well, the parallel, one of them's not moving. One of the variables wouldn't be moving because they're stationary. They're side by side.
There you might be thinking about a horizontal or a vertical line, in which case, yeah, one of the variables goes away because the coordinates on that line share a common value for x or a common value for y.
What's the biggest example of parallel lines? BSU.
One of the key skills to take away from Module 4 is the ability to look at an equation for a line and to read off of that equation that line's slope. So looking at our original equation, y equals negative 5x plus 9, what would you say is the slope of that line?
Say it again.
Yeah, how do you know? Yeah, exactly. It's where m is. It's attached to the x, and the y is by itself on the other side. So we can look at that original equation and directly, without having to resort to finding the coordinates of 2 different points on it and then doing y2 minus y1 over x2 minus x1, even if we did do it that way, we would take the long road around the mountain just to end up at the same slope that we get just by reading it off the equation, negative 5. So we just took the shortcut through the mountain instead. So the slope of the original line given to us in this problem is negative 5.
Okay.
So now we want to use that information somehow. We're trying to find an equation in this problem of a line which is parallel to the original. What's true about the slopes of two parallel lines? Peter? They're the same. So in this little chart over here, and this is also on your quick facts sheet, the slopes of two parallel lines are exactly the same as one another. So without doing any real computation, we have read the slope of our original line off of the statement of the problem to be negative 5. And because we want a parallel to it, we want our line to have that same slope as the original. Which is great on a multiple choice question, because immediately we can get rid of any of the choices that don't have a slope of 5.
So the word parallel, just take.
Right.
Yes.
Which is why my question from before was, which answer did you think it would be? So if your answer was A, C, or E, there are only two things that happened. Either you didn't realize that the slope you would be using is parallel, like you didn't know specifically what parallel line meant, or you accidentally just saw that y equal 1, negative 5 as negative 1/5 x instead.
Right. There's another reason that those are particularly effective distracting answers, because if instead of parallel this had said perpendicular, how do you find the slope of a perpendicular line? Peter?
Just be the opposite.
Opposite. There's one other thing that it is too.
And the y-intercept would be the sign would flip.
That's what opposite means here, but so there's actually one more thing. Opposite reciprocal. In other words, change the sign on the slope and also turn the fraction upside down. So if this question had asked for perpendicular instead of parallel, we would have taken this negative 5 over 1, and we would have flipped it upside down, and then also added another negative sign to it, so that the slope of a perpendicular to this line would be 1/5. Right? That's if we were asking for perpendicular. But here we were asking for parallel, and parallel lines have identical slopes. So we want negative 5 to be the slope of this line.
What is 3? What is that ordered pair actually showing us?
And horizontal?
No,
Vertical.
So both, right?
both. It's a point on the x and y plane. So 3 represents the x-axis, so if I go over 3 and then up 6 points, that's what that point is located.
Right. So that point is telling us that on this line, the one that needs to answer our question, if the x-coordinate of a point is 3, then the y-coordinate of that point needs to be 6. And connecting that information into our equation tells us
We now have
that if we,
two given answers for variables.
right, if we put in a 6 for y, then we had better put in a 3 for x. And now the only unknown, which we now can solve for, is the y-intercept b. What's negative 5 times 3? Negative 15. So 6 equals negative 15 plus b. And how do we get the b by itself? I would divide if I were multiplying here. I think we're
When you say the
okay.
wrong thing, take a break, pause, rethink it through.
So we find out here that b is equal to 21. And because we know that b is equal to 21, we can fill in that square with 21. And lo and behold, there's our answer choice.
We don't touch the 9 at all.
So let's put a picture to this problem. So we were originally given in the question a line, y equals negative 5x plus 9. Now you were telling me negative 5 is the slope, but 9 is the y-intercept of that line. So here's 9 on the y-axis. Negative 5 is the slope, which means we can find another point by going to the right one and then down by 5. After all, that's how a slope gives us information. It's the ratio of the rise to the run, which means if I want to run by 1, I should rise by -5 to find my next point. And then connect the dots. So the original line given to us in the problem is a line that looks something like this. So there's the original. And the question asks us to find another line which has two properties. The first property is that that line needs to be parallel to the original. In other words, it has to be going in the same direction that this one's going. And the second piece of information is it needs to pass through a point that the original doesn't actually pass through, 3, 6. Where is 3, 6? Right here. So the line that we produce has to pass through 3, 6, and yet it has to be parallel to this original line that we had. And so parallel means the slope has to be the same. Yeah. So if you like, let's see if I can do this. Nah. We really just have to draw a line that looks exactly the same. So it also has to have the same slope, meaning go to the right by 1 and down by 5. So right 1, down 5. 1, 2, 3, 4, 5. Find another point right there. Connect the dots. And the line that we produce to answer our question had better be that one. And the slope of that line has to be the same as the slope of the original. The original line had a slope of -5. And because our line is parallel, it has to have the same slope as the original line. So what's different about these two lines is their location, which is measured either by the y-intercept, and the y-intercept of the original line was at 0, 9. We don't know the y-intercept of the new line, and that's why we had to go and find it. What we did know that tells us the location of this line is the point 3, 6 that this line needs to go through. But then by plugging 3, 6 into our equation, so that's why we're choosing to make x 3 at the same time that we make y 6, because that tells us that 3, 6 is part of this line. Following that logic through, let us solve to find out that b, the y-intercept of our new line, is 21. So if we were to extend this line all the way up to the y-axis, however we do that, it would extend all the way up to a point on the y-axis. Let me see if I can actually sketch this, because it's off of our grid. But the point at which this intersects the y-axis is going to be all the way up at 21.